Okay, let's go to the third part. This part we have Lin Chen Boon, Head of Product and Marketing, Asia Pacific region of Trina Solar. Lin is handling product and marketing in APAC at Trina Solar. He joined Trina in November 2011 and has been responsible for product management, training and promotion of new products to APAC customers. He has over 10 years of PV industrial experience and supporting a broad base of customers in different segments on products and technical matters. Hi, Lin, can you hear me?
Yeah, hi, Carol. Yes.
Thank you
for the introduction. Yes.
Yes,
okay.
yes, okay. Yes, it's your turn.
Okay, thank you. So let me share my screen. Okay, I hope everyone can see my screen now.
Yes, yes, I can see your screen.
Okay, thank you. So once again, thanks to everyone for the time today to participate in the webinar. I'm Lim, product management from Trina Solar. So myself, I'm based in the Singapore office, and from here we are supporting the Asia Pacific market. So just a brief company background introduction. So Trina is founded in 1997. So this year is our 25th year company anniversary. So I'm proud to say that we are one of the very few solar module manufacturer that is able and actually realize the warranty of 25 years on our solar module, as we are still around after 25 years and more years to come. So this is our global footprint. As of Q1 this year, we have cumulative shipped over 100 gigawatt on a worldwide basis to all our customers. And currently we have about 19,000 members in our Trina family. So in terms of reliable brand, we have been around for a long time. And in terms of the top most bankable module supplier, we are 6 times in a row ranked most bankable by Bloomberg New Energy Finance. At the same time, we have been participating in the PVL scorecard for the last 8 years. And throughout this period of time, we have been always in the top PVL performers. Over the last 4 years in Asia Pacific, we have shipped almost 13 gigawatt of modules, and we are definitely one of the top 3 module suppliers in this region. So in terms of leading technology, Trina, we have launched our 210mm Vertex ultra high power modules since early 2020. And from there, we have moved from the 500 watt to 550, 600, 660. So besides this, we are also into the N-type technology. So we have commercialized some of the N-type models. And besides, on top of this, we also have a reserve HJT technology, which is in conceptualization and also planning for mass production. So this is just a brief look back on what has happened over the last 10 years. So you can see we have come a long way from a 290 watt panel. Now we are looking at 660, which is almost like 2.5 times increase in the power bin of a single solar module. So it has been especially exciting over the last 2 years, where we see exponential increase in the power bin of 50 watt and above every half a year or 1 year. So when Trina first launched the 600 watt plus modules, there was only 39 companies in this PV Open Innovation Technology Alliance. But fast forward to now, we have almost 90 companies that's part of this alliance, comprising of both the upstream, downstream, and also the BOS and also other testing and certification bodies. And if you look at the global trend of how it will develop in terms of the cell size and the cell capacity, we can see that from a third-party studies or third-party report, the supply of 210mm cell is expected to grow rapidly over the next 3 years. At the same time, you also have module capacity by 210mm also growing rapidly. So now 210 is definitely now and the future to come. And there's from this study, we can see that there's sufficient supply capacity for the 210mm cell size in the current PV market. So this is our Trina Vertex family. Total, we have 5 series. On the left is our Vertex S series. So this one is targeted mainly for the residential rooftops, 435 up to 435 watt. Then we have the 18, 19, 20 series, which range from 510 watt to about 600 watt. So this can be utilized on rooftop projects and also some utility projects. And we have our biggest, highest power bin, the 21 series up to 370 watt. So this has been deployed in some of the large commercial rooftops and also in ground-mounted utility projects. So these are more details of our current product piece in terms of the size and the weight. So we are using, for the 18 series, we are using the monoperk 1/3 cut 9 bus bar, and for all the others is a monoperk half cut 12 bus bar. So some of the characteristics or some of the technologies that we are putting into our Vertex modules. So starting from the left corner, top left corner, we are using the 210 mm, and our design is based on low voltage, high current, which will enable more modules to be connected per string. And given the higher dimension, the bigger dimension of module now, we have also made some changes to our structures to reinforce it so that it can meet the loading requirements. So also on the bottom left corner is our integrated delivery solution, because the modules are bigger now, so we have changed our packaging, which I will introduce later. Then on the right top corner is our non-destructive cutting. So this is in line with using a larger wafer size. So traditional high temperature melting, we have changed to a low temperature laser cutting, which give a smooth cut edge and maintain the mechanical strength of the cut cell. So we are using the high density interconnection method. So this will help us to optimize the dimension of the module by narrowing the gaps between each cell, and we can also increase the module efficiency by about 0.2 to 0.3%. And also multi-bus bar, so this is in line with using a larger wafer size. The last one is a quick installation, which we are planning, and we'll have more information available in the near future. So this is the product details of our 670 watt. So you can see basically it incorporated all the technologies introduced in the previous slide, and it's based on a low voltage, high current design. And when we compare to others in the market, we can get much more higher string power. So these are some of the technical specifications. We can see in terms of the module efficiency, we are able to get about almost 21.6%, and our voltage is lower. The VOC is lower compared to the others. But the point here, note that our current is also higher as compared to the others. So we have done a couple of third-party studies, value assessment, together with third-party agency. So this is one of the more prominent one, together with Frankfurt. So based on the 2 case study in both Germany, using a 10 megawatt monofacial fixed tube, and also in Spain, a 50 megawatt bifacial 1P tracker. So we do see that the results are quite conclusive for both the fixed and mono. When we use a higher power bin, we're able to get cost savings, capex savings of up to about 0.95 to 2.04, and LCOE savings of about 1.9 to 4.1%. Where are the savings coming from? So basically, the savings are coming from the installation, the electrical systems, and also logistic costs. So with a low voltage design, we're able to increase the single string power, and this will help us to save the DC cables, the connectors. And because the power bin is higher, so we also reduce the total quantity of modules required to be installed for each project. So this will save on the labor cost and also on the mounting structures. So besides deploying our high power bins on the ground mounted projects, we also have deployed them on the large CNI rooftops. So this is one case study that we have done in China. So this is using a string inverter, about 1.6 megawatt system. So over here, we compared with the lower one, the 545 watt module. So you can see the inverter use is the same, 7 units of inverter. We can connect 30 modules per string as compared to 28, and the overall string power is higher. So we can see that the string amount is significantly reduced, and also the total module amount is also reduced. With that, when we do the cost breakdown, then we can see the cost savings coming from the PV cables, the mounting structures, and etc. So for this particular case study, we are looking at a savings of approximately $0.005 per watt. So this is just to show when we use a high power beam modules, total number of modules required to be installed are reduced. So this saves on the installation time and also on the labor costs. So Trina is one of the first company to introduce this kind of large dimension module. So we have done extensive testing to ensure our module reliability. So first is on our product optimization design. So we can see that based on the length and width is bigger compared to the conventional module. So to support this larger dimension, we have also optimized our frame structure design, which we have introduced for this larger dimension modules. So these are the 5 other enhanced tests that we have done besides the standard mechanical load test. So in terms of the standard static load test, we are fully compliant with the IEC standards of 5,400 Pascal front and 2,400 Pascal back. And for the tracker, depending on the scenario, can range from 2,400 Pascal front to 2,400 Pascal back. So on top of that, we have also tested our heel impact. So we have upgraded from the 25 mm to the 35 mm, and basically we have passed all the tests as required. So this is just an example of how the test is being performed, and we have passed both tests for our monofacial and bifacial. So besides this, we have also performed the enhanced dynamic load test, which is a ±1,000 Pascal at 20,000 cycles. So you can see after the test, the power degradation was only about 0.1%. And the most exciting will be the wind tunnel test, where we try out from the wind speed from 30 meters per second all the way to 62 meters per second. So namely at the 53 meters per second test, we're able to pass for both the screw using the bolts and nuts installation method, and also the hybrid method, which will be those screws plus the clamps. So as mentioned, because our modules are larger in dimensions, so we have changed our packing. On the left is the conventional 2-stack packing. On the right is our new vertical packing. So this is how it looks like inside a 40-foot container. So we can see, although the pellets per container becomes less, but the overall power per container is increased because of the higher power bin each module. So these are some of the case studies projects that we have supplied using our 660 watt module. So these 112 megawatt tracker projects installed in China. So you can see on the right is our stand supporter. So this is something that we provide to our customers to assist them in the unpacking of these vertical packing modules at site. So this is another example of ground-mounted projects in Japan. So this is how we can move the pellets around on site. And this is a 700 watt module that we have deployed on a rooftop. So this is one of the project in ASEAN, a 0.54 megawatt 600 watt monofacial module. So as mentioned, Trina is using a low voltage, high current design. So we have worked with the major inverters company in the market to make sure that we have a compatible model that can work together with these high current modules. So you can see based on our design concept, so we propose the solution of using 1 string per MPPT to connect with the inverter. And generally, we still satisfy the requirement of a DC-AC ratio for a distributed PV system. So of course, I think for ground-mounted projects, there's no issue because central inverters or the high power string inverters like 200 kilowatts and above are fully compatible with Trina modules. So to further help our customers, we have also put together a website where you can check on the modules that you are using and the corresponding matching inverters. So in the event that you cannot find anything, you find the models or the brands that you need, please feel free to connect with us, and then we can help in the selection and proposal. So based on our track record, we have signed more than 25 gigawatt of orders and more than 20 gigawatts of shipping of Vertex modules on a global basis. So these are some of the other case studies, already commissioned projects, some of them in China. Then we also have in the Asia Pacific region, the rooftop projects using the large dimension high power modules. Now, of course, ground mounted projects, and also we have deployed in our floating projects in Asia Pacific. Okay, with that, I've come to the end of my presentation. Thank you everyone for.